Question number 12, you are given three vectors A, B and C. You want a vector D which is perpendicular to both. So here vector D is perpendicular to both vector A and B, remember. So therefore vector D must be, you can write parallel to the cross product. You know, the cross product is always a vector which is perpendicular to both. So therefore you can say that the vector D must be k times vector A cross vector B, remember. What about k? K is any scalar, remember. K belongs to R here. K is a scalar. Fine. Now this cross product can be obtained very easily. Now let's find the cross product first. So I'm just finding cross product here using determinants I, J, K. What about vector A here? That's 1, 4, 2. What's vector B? 3, minus 2, 7. Just repeat A. What's vector A? 1, 4, 2. What's vector B? 3, minus 2, 7. Let's find this. So here you have 28 plus 4. So 32 I cap minus 7 minus 6. It is just J cap plus here minus 2 minus 12. So minus 14 K cap, minus 2 minus 12. So this is the cross product of these two. So therefore vector D must be k into this one, 32 I cap minus j cap minus 14 k cap. Now how do we get the k? So using one more condition given in the question. What is that condition? Let's write that condition here. That condition is vector C dot vector D equals to 15. So dot product of this one with this must be 15. So we'll get the k from there. Let's do the dot product. So 32k into 2. So it is 64k. This into 2. This minus minus will be plus k. Minus 1 plus k. K is there, remember. Minus 14k and here 4. So it would be how much? Minus 56k equals to 15. What I did? Dot product. I repeat. 32k into 2. 64k. Minus 1 plus 1. You know definition of the dot product. But k is there. So plus k. Minus 14k plus 4. So we'll get the minus 56k. So from this you will get the value of k, remember. So 65 minus 56, so it will be 9k equals to 15. So therefore k will be here 15 by 9, which is nothing but a 5 by 3. So this is k. Now we place the value of k here. So therefore vector D equals to 5 by 3, 32 I cap minus j cap minus 14 k cap. If you want, you can just take this one inside here. So 32 into 5, you know it is here 160 by 3 I cap minus 5 by 3 j cap minus here 70 by 3 k cap. That's required vector D. This is a vector which is perpendicular to both vector A and B and dot product with vector C equals to 15. I repeat, see what I did. Let's recall, you are given that D is perpendicular to both. Now you know that the cross product is always perpendicular to both. That means these two vectors must be parallel. So they must be multiple. That's one thing. Now I got this placed here. So you got the vector D. And therefore the dot product equals to 15. If I use this, I have the value of k and then just placing the value of k over here, you will get the required vector. Next, in the 13th question, you required sum of these two vectors. So let me add these two first here. So we'll get the lambda plus 2 I cap plus 6 j cap minus 2 k cap. Right? This is the sum of these two. Now what's given in the question? Just read the question. You are given that scalar product of this, scalar product means dot product of I plus j plus k, dot product of this vector with a unit vector along the sum of these two. So you need a unit vector in the direction of this. How do we get this? Vector upon its magnitude. You know, we did thrice in the previous session. So you have here lambda plus 2 the whole square plus 36 plus 4 equals to 1. This is given. Let me repeat this. What's given to you? Dot product of this vector I plus j plus k, dot product of this vector with the unit vector in the direction of this. How do we get the unit vector in the direction of this? Vector upon its magnitude. So I wrote the vector here upon its magnitude. So lambda plus 2 whole square plus 36 plus 4. Lambda plus 2 I cap plus 6 j cap minus 2k. And this dot product equals to 1. This is given to you. Therefore, now the question is just simplification. This is a scalar which you can take on the other side. This into this. Here you have 1 into lambda plus 2 plus 1 into 6 plus here 1 into minus 2. 1 into lambda plus 2 plus 1 into 6 plus 1 into minus 2 equals to this expression over there. So here this is lambda plus 2 whole square plus 40. Now here what we'll get? Lambda plus this is 6 minus 2. 4 plus 2, 6 equals to, let's write one more step here. Lambda plus 2 whole square plus 40. We want lambda, so I'll just square it. Whole square equals to lambda plus 2 whole square plus 40. So lambda square plus 12 lambda plus 36 equals to lambda square plus 4 lambda plus 4 plus 40 here. So lambda square will get cancelled. This is just 8 lambda. Here equals to, will get the 8, and therefore lambda equals to 1. The only important information is this one that's given to you. Dot product of this vector and the unit vector in the direction of sum of these two. So I got the first addition, then I got the unit vector, I did the dot product, and which is equals to 1. This is a scalar, so I can take on the other side this into this plus this into this plus this into this. That's what I did, and then simple algebra. So we'll get the value of lambda. See next question number 14 here. You are given that these three vectors A, B and C are mutually perpendicular. Okay, so let's write this. So this is given to you. The dot product of this one and this one equals to 0. Why? Because they are mutually perpendicular vectors of equal magnitudes and their magnitude. So magnitude of vector A, magnitude of B and magnitude of C, they are equal, say K. Magnitude equals to, I'll call that as K. You want to prove that, what you want to prove? Show that, show that this vector A plus vector B plus vector C is equally inclined to vector A, B and C. So what you want to prove? You want to show that angle made by this vector with A, it is same as angle made by this vector with B, and it is same as angle made by the vector C. So angle made by this vector with these three vectors are equal. Okay, so let's do. You need to use just the formula for angle. Let's take, I'll write theta 1, that's angle between these two, vector A plus vector B plus vector C and vector A here. Fine. This and this I'll take as theta 1. So what's the formula? Let's recall. So therefore cos theta 1 equals to vector this dot vector A upon its magnitude. So magnitude of this into magnitude of this vector. Fine. So cos theta 1 equals to A dot A, you know it's a magnitude of A whole square, plus B dot A, you know it is 0, plus C dot A, you know it is 0, upon this one I'll keep as it is because we don't have information about this, into here magnitude of vector A. What's the magnitude of vector A? We have called that as K. This is K squared. So this is nothing but what? K squared. So 1K will get cancelled. So we'll get just K upon vector with their addition and magnitude. This is called 1. I hope this is just a formula. Can understand very easily. Let's take theta 2 be angle between A plus B plus C and vector B. So therefore cos theta 2 equals to the dot product A plus B plus C dot vector B upon their magnitude. Formula to get the angle between two vectors. Now do just open this bracket, distributive property. Vector A dot vector B is 0. B dot B, magnitude of B whole square. B dot C, which is 0, upon magnitude of this vector. What is this? This is K. You know this is K squared. So this much is K squared, remember. So 1K will get cancelled again. So K upon vector A plus vector B plus vector C. Call this as 2. And same way you can show that cos theta 3, I'll just directly write here, equals to K upon magnitude of this vector. Same way you can just do it. Call this as 3. You write theta 3 as the angle between this and vector C. That you need to write, remember. Okay, and therefore cos theta 3 is this. So from 1, 2 and 3 you can say that from 1, 2 and 3 vector is equally inclined, means it makes equal angle, equally inclined to these three vectors A, B and C, and therefore proved. Right? That's what you want. Fine. Next question. What about next question number 15? Question number 15 here. What's the 15 question says? You are given this. There's this dot product with this one. So here again we have plus, I suppose, equals to magnitude of this whole square plus magnitude of this whole square. This is given to you. You want to show that A and B are perpendicular. That means the dot product is 0. So we just use distributive property. This dot this. Vector A dot vector A, that is magnitude of A whole square, this dot this, vector A dot vector B, plus this dot this, vector B dot vector A. We did it earlier number of times if you just recall. B dot B, that's the magnitude of B whole square, equals to, you have this. This is given to you, remember you are not going to prove this. Both the sides are equal. Now, this will get cancelled, you know, from both the sides. So therefore, what we'll get from this? We are getting this plus this, but you know that these two are equal. Dot product is commutative, you know, right? Dot product is commutative, so this is same as this. Okay, now I'll take 2 on the other side, so dot product equals to 0, and therefore what's our conclusion? Vector A and B are perpendicular. They are perpendicular, remember. Dot product equals to 0 means vectors are perpendicular. Now, double implication. They are perpendicular, therefore dot product is 0, therefore we have this, therefore we have this. So you can just write double implication, right? And therefore proved. Both way. If this is given to you, then vectors are perpendicular, and reverse. If vectors are perpendicular, then this is always true. Fine. Now let's go to next 3 MCQs. There are 4 MCQs. Let's go for those MCQs. So in the question number 16, you are given that dot product is greater than or equal to 0. Just recall cos theta is this, if you remember. Dot product upon their magnitude. In general, theta is from, 0 to pi. Theta is from where to where? 0 to pi, remember. Fine. Theta is from 0 to pi. But you are given that here, this is positive, remember. Now 0 to pi means how many quadrant? First and second quadrant. If this is positive, then the cos theta has to be positive, remember. And cos theta is positive, that means theta must be in which quadrant? Just look at that option. It has to be from where to where? 0 to pi by 2. That's the first quadrant, option B. In general, theta is from 0 to pi by 2, that is this 2 quadrant, 0 to pi here. When it will be in the second quadrant if this is negative, but here you are given that this is positive, that means cos theta must be positive, and cos theta is positive, that means it has to be from where to where? 0 to pi by 2. If I ask the same question like this, that this expression is less than or equal to 0, for example, then your answer will be this quadrant, that means theta must be from where to where? Pi by 2 to pi. Fine. This is not you are asked, just for information I'm telling you. Okay. Next question, question number 17. These are the 2 unit vectors. Okay, so magnitude equals to 1, magnitude equals to 1 here. Theta is angle between these two. Therefore, what is cos theta? Just their dot product, remember, because upon their magnitude will be 1. Okay, so cos theta is this. Then this is unit vector if what? So here, if the magnitude of this vector equals to 1, it implies just square it. Whenever you have magnitude, you just square it. So I'm just squaring, so equal to, you have 1. Now I'm expanding this. You know how to expand this. I did it number of times. Now I'll not repeat. Equals to 1. This is 1. This is also 1, remember. So here 2 times this dot product equals to, this is 2. If I take on the other side, this is minus 1, remember. So dot product, but what is the dot product? It's a cos theta. So cos theta equals to how much? Minus 1 by 2. And therefore, now if you just look at that option, immediately you can say that theta has to be pi minus pi by 3. and which is nothing but the 2 pi by 3. You know now very well from trigo. Remember, I repeat this is 1, this is 1, 2. I'll take on the other side. So you're left with minus 1. Therefore, dot product equals to minus 1 by 2. But what is dot product? It is cos theta. So cos theta equals to minus 1 by 2. And therefore, theta has to be what? Pi minus pi by 3. Which is nothing but 2 pi by 3. Which is option D here. Okay. So here we want the values of these three dot products. This one, if you remember, this and this you can answer very easily through that cyclic procedure. I, J, and let's write K. This, and this. You know here, what is this? I, J cross K. This cross K, so it is I cap. This one as it is dot J cross K, it is I cap. Fine. Plus now J cap as it is dot I cross K. It's in the reverse order, so it has to be minus J cap. It's in the reverse order, so opposite sign. Plus K cap I cross J, which is nothing but the K cap. Now what is I dot I? You know 1. Here minus 1 as it is. J dot J 1. What is K dot K? It is just 1. So final answer is 1 here, which is nothing but the option C. Okay. Next question, 19th number. Theta is the angle between two vectors. Okay, so you have cos theta equals to this. The dot product upon its magnitude, remember. And you are also given that the dot product equals to cross product. And you are given this dot product with magnitude equals to their cross product. That's also given to you, remember. Now when we have cross product, this also reminds us this formula. Magnitude of cross product upon individual magnitudes, you know this. So here you can just put the modulus also. So you can say from this that cos theta equals to what we'll get? Sin theta. These two are equal because these two are already equal here, remember. So both the numerators are equal, you are given. Therefore cos theta must be sin theta. And from the options here you can say that theta has to be pi by 4, which is nothing but the option B here. Now go through the examples. All examples are important, remember. Don't ignore it. Try yourselves. I'm sure all are based on theory only. So do it. That's for you.